Okay, great to see everybody. Hope you enjoyed your lunch. We have a fantastic panel. I mean, just lots of experience, so looking forward to getting into it. Let me just give you a quick introduction. Again, my name is Bart Denny, and I'm with VIEWAR. We're an Austrian company that has a AR enterprise solution primarily for very large facilities where you're able to use augmented reality for addressing some of those really pressing problems in today's workplace, whether it's to operate more efficiently or to address the skills gap that a lot of companies are facing these days. We do have a work instruction workflow module together with remote assistance. And then the sort of third leg of the stool is indoor navigation. So we are taking digital twin data from Matterport scans or other LiDAR scans and enabling persistent augmented reality throughout. And then with that, you're able to save lots of time just simply finding the right thing faster, especially over large facilities. It's a really, a big time saver. So that's combined with that workflow product, which is very intimately tied to that so-called digital twin. So needless to say, we'd love to talk to you. We've got a booth here. Stop by, say hi. So without further ado, let's bring up our panelists and get into it. So yeah, let's give it a big round of applause for our willing. Yeah, please come on down. We couldn't decide on the walk-up songs, so we're going quiet, but. Without further ado, let's just get everybody introduced and a short intro. Zohair, you want to kick it off?
Sure. Hey everyone, good afternoon. My name is Zohair Mehkri. I'm part of Flex, and I'm responsible for the Flex Digital Twin organization. So nice to be here and meet everyone. Thank you.
Yeah, hi everyone. My name is Paul Davies. I'm a technical fellow out of Boeing's Research and Technology Group. We develop solutions for commercial and defense, and my work is specifically focused on XR and work instructions and factory use cases.
Hi, everyone. My name is Austin Coglianese. I am the manufacturing augmented reality trainer with Fastenal. We're using augmented reality to train all of our machinists and get them all up to speed.
Hi, everyone. My name is Nobel Vale. I'm with Bristol Myers Squibb. I'm a principal scientist with the group. However, I've been a big XR enthusiast, and we've implemented XR in many different aspects, such as remote telepresence, training, immersive training, and many other things that make the scientists work in the labs and manufacturing environments a lot easier.
Hello, everybody. I'm Jeff Shein, Staff IT Technology Analyst for Regeneron Pharmaceuticals. I know that's a mouthful. I was talking to my colleagues in the Uber. We're like the SEAL team. We come in and do proof of concepts for digitalization, digital twins, XR, VR, launch it, and then hand it off to the business to run. Good to be here.
Awesome. So we're here to talk about remote assistance and augmented work instructions. And so to start off with, I thought we could kind of just tease out a bit more about really the core new value proposition that these tools can bring, because this is a new technology. It's really just starting to come into its own. And I think we'd all up here agree that these are proving to be incredibly valuable technologies. So let's kind of just dig into these two and get a little more understanding of how these folks are getting some of the value. So remote assistance. I mean, I like to think about remote assistance as the magic of getting two people in the same room, two or more people in the same room working on the same problem, especially when it's a spatial problem, a spatial problem which is so endemic to facilities, workplace management, where there's just stuff going on. And so that kind of magic power is quite, at the heart of what this technology can deliver. Needless to say, recently we had a little episode that really brought home the importance of dealing with remote work. And so the pandemic clearly was a bit of a spur to a lot of these projects. I thought we could start with Jeff telling a little bit about how you really started fast forwarding things as the pandemic hit. Yeah.
Yeah, thanks, Bart. Yeah, the pandemic was pretty much the catalyst for Regeneron to be able to get into this space, a blessing and a curse, if you will. Look, at Regeneron Pharmaceuticals, we make medicine to save lives of people. So during the pandemic, as you know, you'd maybe go to your local Starbucks, you'd see a sign that says, we're closed, so you have to go find another Starbucks. That's because people had COVID, they couldn't work. We're not Starbucks, and we have to continue to work. So they came to our group and said specifically, Jeff, how do we continue to work like we normally did, with also following what the CDC had mandates? So we sent half of our work population home. So inside of our process areas, right, we would have dozens of people working side by side. Management would be there for oversight. So we had to figure out a way. How do you still work? So the first thing we had to do is look at a piece of hardware. We chose the RealWear assisted reality, so it's not fully augmented, and that's because it was industrial ready, fully gowned up. These to get into a process area costs hundreds of dollars and almost an hour of your time to get in. So just to send somebody in to check something was a problem. So we chose the RealWear device. It was we had to get that clean room approved. So it was industrial ready. Once we got that, we chose a platform, right? I'm sure I spoke to a lot of you. There's so many platforms out there to do remote assist. What does it take? You see what I see in my camera, and you don't need to be in the same room as me. We chose Augmented. They're here today. Big shout out to Augmented. So they were our remote assist platform. So now we've got half the workforce out, and we were still able to work, right? With people out. So just with a simple voice command, you put it on your head with a simple voice command, call Jeff Hoffman. You can be speaking to him in real time. And Jeff now can see what I see or what the BPSs in the process area see in real time. If there's a problem in front of a piece of machinery, they can hear and see what the operator sees and then annotate on their screen. So in real time, hey, I'm looking at a piece of machinery and this alarm is going off. Well, they can freeze the image, annotate on it, and that saves you time to come in and do it. One of the other use cases was, we're commissioning a fill finish plant. So instead of sending people to Germany to take a look at this factory acceptance testing, we would now send hardware over there. So you save thousands of dollars just by sending hardware, and the hardware is pre-configured. The factory people can put that on, and we could do remote assistance long distance. The other thing, one last thing is we're regulated by the FDA. So again, the FDA still has to come in and inspect us at any time, but because of COVID, the FDA couldn't come in, so we had to perform remote inspections. So we chose the HoloLens so that you could integrate with the Teams call, and in real time, again, everyone is online collaborating, and the FDA is saying, okay, go here, go there, and in real time, the benefit of this new technology to not being in the same place at the same time was just game-changing for us.
Awesome, thanks, Jeff. Next up, Nobel. I mean, you kind of, was this story similar for you, or to share a little bit about the value that you've seen derived from remote assistance?
Absolutely very similar. I mean, I'm from another biopharmaceutical company similar to Jeff, and everything he said was applicable in our company. We had to keep working, we had to keep manufacturing. So he used the RealWear, we also used the RealWear. We used a different software partner named Apprentice.io, but it still was able to accomplish the same things, being able to have someone's eyes and ears remotely to a process in real time. We also had work similar to what Jeff mentioned, people domestically and internationally. So people couldn't travel, but at the same time, we still needed to assess facilities. We still needed to manufacture our medicine. And the pandemic was good in the fact that it expedited a lot of the IT work that was required to get a lot of this infrastructure in place. Prior to the pandemic, we were looking at XR and AR technologies for different aspects, such as looking at how we can automatically capture data, how we can sort data, and et cetera. But the pandemic has definitely allowed us to pivot to that remote support and work instructions, because this is what the immediate need was. And what was beneficial there was the leadership saw the benefit of remote telepresence and saw the power of the technology. So then they asked, what else can it do? What is next? Currently today, obviously with a lot of people traveling again, we've had less use of remote support. However, it still creates a benefit because maybe only one person in the team travels, and then that person uses the headset and can showcase it to the rest of the team. Yes, maybe people want to travel, maybe people want to log their miles, so that's where maybe there's some less use. But however, there are partners that are maybe located in different parts of the world or the country that maybe people don't normally want to go to. So that's where we still leverage that technology. And additionally, you have to always look at what is the ROI for a lot of this technology. And if it has multi-use, that's going to help it a lot more.
Awesome. Zohair, you've really been doing remote assistance since, I think it was 2017, yeah? 2016, yeah. So, yeah, share kind of like what was the impetus before the pandemic, and how did that kind of change once it did strike?
Yeah, absolutely. Our business is a little bit different. Maybe it's a manufacturing company. So we manufacture. Well, you're manufacturing also, but we manufacture products for a lot of different segments and industries and customers around the world. And so we're contract manufacturing. So we're working essentially. We're just working with the customer on what they need and the units and the area and the volume and the geography and so on. So we started looking at XR because we were trying to be faster in our time to market, right? We were trying to help our customers be faster in their time to market to their customers. So we started looking at remote assistance from just a solutioning perspective of what can really help us be faster. And sometimes, you have decentralized regions of expertise, right? You may have one region that's stronger in automotive engineering, one that's stronger in plastics engineering, one that's stronger in we call printed circuit board assembly, right? So you have all these different areas of expertise, and how do you bring them together when you need a product somewhere in the world? So we started with that, and we had a little bit of for us, because we were a little bit earlier, we couldn't find the startups and the companies and the software providers as much early on. So we were developing our own software, which we stopped doing because we failed miserably. But it was a really good learning experience for us, and then we started to work more towards market movers and industry players that helped us, that we partnered with, that kind of helped us accelerate. So yeah, it's amazing to see the industry change in the last, whatever it's been, 6-8 years. So it's been exciting.
Yeah, absolutely. I really do think it is a superpower to really get that feeling that people are together working, and so yeah, it's clearly going to be with us for a while. So, turning to work instructions, using augmented reality to provide kind of a visual guidance. Tell us, Paul, a little bit about the platform that you've built to help deliver these work instructions.
Sure, yeah. So the main platform I think Bart's referring to is called Bart, the Boeing Augmented Reality Kit. And we've got quite a bit of experience in looking at different use cases of providing work instructions in the airplane factories around the country and in fact around the world that Boeing has. A couple of the main use cases we've identified and tried to capture the value statement would be installing wiring where it can be incredibly complex designs, and trying to understand wiring routing using like 2D drawings, or even if you have a 3D model on a tablet or something. It's just really difficult to follow, very complicated installation processes. So we have one use case where we've built a pipeline to convert all the engineering data into formats that we can use in XR devices like a HoloLens. And we've put HoloLenses on the mechanics, and let them use the tool to actually, we call it pre-write wire bundles in several of the aircraft models that we build. Got a lot of data on the effectivity of that in terms of time savings and quality improvements, and is quite impressive. Another one of the use cases, probably one of the most common ones we see around the factory, is locating features or fasteners. Frequently, it's usually fasteners going into holes. If you can, next time you're on an airplane, if you look out of the wing, you'll see hundreds of holes down the length of the wing and all across the fuselage, thousands of fasteners. And getting the right fastener in the right hole or performing the right inspection procedure on different holes doesn't sound like a hard thing to do, but when you have hundreds of them in a row and certain ones get different fasteners, that is just ripe to make mistakes on. Because if you're trying to get that information from a drawing, and you may be like counting fasteners and you're trying to figure out which one you've got to put a different fastener, counting holes, which one gets a different fastener, pretty easy to get the wrong hole. So taking advantage of like the spatial alignment of augmented reality, that takes away all that process and just shows a very clear view of which fasteners or whatever goes in which hole. So that's a very common use case around Boeing. And then I'd say the third main one would be validating assemblies by basically just overlaying the CAD design on top of the product. Several examples of that. A big one would be brackets on fuselages. There's hundreds of them, several hundred on the interior, and to make sure they're all there in the right place, installed correctly. So you can either do that with paper drawings, takes a long time, prone to error, or if we can just align the CAD model to the aircraft, to the fuselage, becomes a much simpler problem, much less prone to error. So we've got a lot of experience in doing that too. I think generally any time you can bring digital work instructions or even really the airplane design or design of any product closer to the person who's building it is going to produce good results in several different ways. And we, like I said, we've done quite a bit of work to capture, quantify what that means for us.
Awesome. All that talk of fasteners, that's right up your alley there, Austin. But you're using it for way more than just fasteners, right? You're using it throughout your facilities?
Yes. So, I knew I was going to get the fastener lead in on that one. But we've focused on how to capture the tribal knowledge of all of our different machinists. So we have a wide variety of machines and specialties that we offer within Fastenal manufacturing. And to get an individual operator up to the same page as a veteran operator, it's something that, without AR just takes quite a bit of time. And the problem then is that everyone, even though you're trained the same kind of a way, everyone then finds a little different way of doing it or their own tricks to it. One machine is going to have like a little quirk or something that another one won't. And so what we were focused on especially is then to get all of the best practices, not just the stuff that you would get in your standard training or your SOPs, but the things that the operators themselves say is the most important, put it all together and package it in such a way that we can give this to anyone and instantly get them up to speed so that they are not just producing parts, and being productive in that way, but they've also accelerated their own career and are buying in more as they see their own development in that way.
Yeah, awesome. Okay, so we've now got a pretty good understanding of how this stuff is being used to drive real value. Let's dig in now to some of the challenges and some of the great learnings that this group has come up with in terms of overcoming some of these challenges. And with augmented work instructions, as remote assistants, like you can slap those real wear glasses on people and they're getting value almost immediately. Work instructions are a bit different because of the challenges that come from capturing that tribal knowledge. There is content that has to be created. So let's talk a little bit about the challenges of creating content for work instructions, and we'll look at two different sort of challenges. Paul, you kind of got a very technical challenge, real 3D art challenge, right? Tell me a little bit about what that problem was and what you've done to address it.
Yeah, that's probably the number one challenge that we faced is getting the content scaled, translated in a scalable way so we can use it. So, we have, just huge amounts of digital 3D engineering data behind all of our airplanes and products. Now, it's one thing, just to, someone could easily manually say export a model and maybe process it through Pixies or something, and then import it into Unity and build an app and then install the app on the HoloLens. But that doesn't scale very well, because if you do that, you've kind of, they say, broken the digital thread in such that if the design were to change or an assembly process were to change, then someone's got to know that and keep track of it and update the app and redeploy the app, and that's not the way you want to do it. So building automated pipelines that pull released engineering data and are notified when there's a change or a release of data, process it, convert it, prepare it, package it, deliver it over, say, a network to a mobile device. That's been the main challenge that we have. And we don't actually, I don't say we actually create any content, we only translate content. One of my big thoughts on this is that if we have to spend time creating content, then it really eats away at the business value, because especially if you're creating new 3D content, especially step-by-step, say, work instructions, very time-consuming to create and also to maintain. So we've seen a lot of value in just reusing existing, mostly just design models that we already have. It may not be, strictly speaking, a work instruction, but it is used to build the product. So just converting what we already have and focusing on scalability and true integration. So as I mentioned, when changes happen, the next time that content is viewed on a HoloLens or whatever, you're seeing the latest, you're guaranteed to be seeing the latest release. That's been the hardest challenge of what we've been working on. Briefly, just secondly, in terms of the challenges behind work instructions, is accuracy of alignment. If you're going to spatially register some content to a product and you're going to guide someone's job using that view, you have to have some guarantee or some understanding of the level of accuracy of the registration between the virtual content and the world. So that can be done very accurately if you're willing to install expensive infrastructure, external tracking systems, but we don't want to do that. That doesn't scale very well either. If you're going to use inside-out tracking, which most devices do now, that becomes a more complicated question of how accurate can you really get the alignment. And going back to the wiring use case, that's one of the reasons why we actually started with wiring, because the accuracy requirement is so much lower, because the wire bundle is flexible by itself. It's never in the exact position that it is in the model. So we started, with wiring, but we understand, there's limitations. You would never show someone, say, where to drill a hole using a HoloLens, because, it's just not going to be, totally accurate. So those are some of the two big issues, yeah.
Especially in an airplane. Yeah. Austin, fair to say that you're on the opposite end. I mean, you're on the very front lines of creating that content, aren't you? Talk about the challenges there.
Yeah, so I'm pretty much on the exact opposite end of this. So our position is that we are actually creating original content and such. So for our use of scalability and such, we use the tactile brands of AR software. So we use Manifest and Manifest Maker, and we're able to, especially with Manifest Maker, use just a regular iPad and record someone as they run through their job. And then we can take the little elements of the videos that we create and immediately just slide it on over. And within a few minutes, we have the framework of an entire new set of work instructions. And then that's not even mentioning all the other tools that we have where we can just scan a set of like SOP documents or like a machine manual, and immediately take all the words and such that are right on the page and drag and drop them. So we have some tools on that end. We also then, so I have a machining background before I started doing the augmented side of this. So my team and we are able then to go out to the machines, we talk with the operators, and we get photos, videos, animations, everything from their kind of point of view, and we're able to put this together in such a way that we really focus on hitting all of the different main learning styles of people, because it really doesn't work if it doesn't speak to your user and to your end result in a sense. So that's kind of what we are doing on a daily basis. Is we're going out, we're capturing the content, we're making the videos, we are, we're writing the stuff, and we have to then rely on the tactile products on that end. Once we put it all together, that's our way of pushing it out. But the focus is, for us especially, is that creating it, making sure that fits everything that we need.
So you're kind of a spatial documentary maker.
Yeah, I guess you could say that, yeah.
So doing that to capture tribal knowledge, and that's a phrase I heard from you too, Zohair. Tell me about the work you've done to really capture that tribal knowledge.
Yeah, absolutely. So we flip back and forth between Paul and Austin, right? So sometimes, because we're contract manufacturers, so sometimes we have a customer that has all of their files. Sometimes we have a customer that doesn't even know how to model, right? And then they have a very tight timeline. So what will happen is they might come to us and say, we have no models whatsoever, figure it out. And then on the other side, we may have someone else that has models, but they may not have all models, or they might have everything modeled, and they want us to take all those models and then create a work instruction as an example, right? So you have all of those different use cases, and it's a range, right? Sometimes you can go back and forth even within the same product, right? One part of the product might have a lot of CAD, one might not exist. So you're consistently having to go back between, as you say, transferring or creating content, right? And so what happens is that when you start to put these work instructions together, when you start to put them on the factory floor, you find that you have pockets of knowledge, kind of like I was saying earlier. Someone might be really good at cable management, someone might be good at mechanicals, and these might be in the same facility if you're lucky, or they might be across the world. And so what you have to do is you have to put everyone together digitally almost in that work instruction, get that knowledge. So we also call it tribal knowledge, which is that you might have people that have been doing this for decades, and they might know that very, very well. And for them, it's just muscle memory, right? So you have to go there, you have to watch them, you have to figure out how they're doing certain things, and then translating that, digitizing that in a way, right? And that can be really tricky because you can't always quantify what they're really doing. Sometimes they'll just, they'll put in a cable, right? And how do you know what's in there? I just know what's in there, right? I mean, they just feel it, and if it's machining, right? They can see it, they can feel it. They have that veteran knowledge, right? And so we have to then take that and talk about how you can transfer that to someone else. And what we found was same thing, was work instructions on paper, on tablets, on mobile devices, even talking, even having a veteran sit and talk to an apprentice, it wasn't helpful. You can have them sit in the same room and explain how they do something, and they still won't get that. And then taking them to the floor, they can do that better there, but if they're not in the same place, it's impossible. So tribal knowledge became digitized. We started having our veteran team members sort of doing these work instructions, talking about it, kind of showing a little bit of finesse that's required, then transferring that to somebody else, having them try it out. And it's trial and error. You have to go back and forth. And because of the fact that you're in our business, right, because of the fact that you're relying on your customer sometimes, you don't really have much wiggle room to say, we need a little bit of time to figure this out, right? We need to have that person fly in or go there or whatever that is. Sometimes you're on a really, really strict time crunch. You may have to go from creating content to transferring it within a matter of hours, right? So it can be very, it's very agile, right?
Awesome. Okay, well, changing gears a little bit. The creating the content is only one small part of it. Another key thing that really has to happen is you got to convince people to use it, right? And let's face it, manufacturing facility, there's an older workforce who may not necessarily think that these kids up here have the right idea. So Jeff, what are some of the challenges that you've seen in terms of adoption, and how have you tried to address those?
Yeah, you said it, the demographics, right? You have the older people that are set in their ways. you know, they love the paper. It's not a one-size-fits-all, though, really. You know, even with some of the devices, right? Even some of the younger generation. So they've got to, you know, buy into it. So you want to have a digital champion, right? Is what we call them. Actually, the industry calls it digital champions. Who from the business can shout at the rooftops that this is the coolest technology ever, right? IT is always looked at as like, you know, IT is making us do something, right? So you want to bring in these guys, the teams, the people who are using it from the very beginning. Give them a seat at the table, right? You know, make them feel part of the solution. So you got to have a really good training program, right, to bring these guys in and train them, and really convince them, you know, why you know, technology is ambiguous sometimes, right? It's like people deploy technology just to deploy it, so it's got to be purposeful, right, and task-based. A lot of the questions that we had in some of our training was, do I have to wear this, you know, my entire shift? So no, it's task-based, right? You have a problem, you grab your headset, you throw it on, you do your task, and you take it off. And then there's a support model, right? So you know, after you launch this technology, are you going to have a hypercare support? Are people going to be able to come to you and figure out, hey, I have a problem, so they don't want to have to call the help desk. So you may have a command center to be able to answer some of their calls. But really, change management is one of our biggest problems of trying to solve. You know, people are set in their ways, and even if you tell them that technology will help them, there is some resistance. So we like to do a show and tell, right? Come, take a look at the technology, try it on, give us your feedback. We could iterate based on it. We could do features that you're interested in, or, you know, it's very, very flexible.
Awesome. Nobel, what have you been doing to help drive that adoption?
So similarly to what Jeff mentioned, it's a big thing about change management and getting the people that maybe aren't fully bought in or kind of naysayers to kind of see how does this technology or how is this way of working actually benefit you. Because I always look at implementing this technology because I want it to be easier for anyone and everyone. So getting that feedback, as Jeff mentioned, getting people to provide that insight on what's easy for them to do and what's difficult for them to do. Because if you have your end users not bought in, then there's no point in implementing a really good technology. And from the business side of it, it's also looking to work closely with IT and ensuring that the solutions that we want to use and the technology that we want to implement is within the standard of the security and things like that IT has to approve. Because the technology can be great on paper, it can be great for the business users to do it, but if IT sees some holes with the security and things like that, then it's not going to work. So I always learn to work with my IT colleagues and make sure that we're on the same page and we both have seats to the table in order to get things moving. Because if you don't have that, then you will constantly have disconnects. You will constantly have ideas that, hey, IT wants to propose this technology, or the business is already trying to use this and we're trying to implement it together. Get alignment there, and it's going to go a long way into the future.
Awesome, thanks, Noble. Let's turn to, you know, these technologies are not cheap. They need budgets. How do you go about building the business case to get these budgets approved? Zohair, you want to share?
Yeah, that's fun. So you know, when you're trying to start out, and you know, the reality of it is essentially it looks like a toy. You know, we're just going to say, right? It looks like a toy. It looks like a video game. And you have a bunch of these engineers or developers, whatever, and they're sitting there with these toys on their head and they're playing games, is what it looks like from the outside. So, you know, then you show up on a manufacturing floor and you're telling them that this is a real thing, right? And this is going to help you and try it on and all the other challenges we heard. But when it comes down to it is that you really have to focus on the return of it, right? So you have to kind of start from your vision, which is what are we really trying to do, and then go down into the business side of it and the functional side of it. You know, we typically look at it in three different levels. Like we have the corporate strategy, the business strategy, and the functional strategy, right? So your corporate strategy is more pie in the sky. It's we want to transform manufacturing. we want to use XR for connecting our people and blah, 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 whatever that vision might be for you. And then you go in that business level, which is, how can we take that vision and have it be more related to your goals? And then you have your functional, which is the KPIs, which is what you're using to track. And so that's where your ROI has to come from. So your ROI has to be measurable, it has to be impactful. Hopefully it's positive. And then you can go back and sort of start to extrapolate from the shop floor to the top floor is what we call it, right? And so it's not easy. Sometimes we still struggle with it. It's not something that you can do overnight. You do have to really kind of work at it and figure out what are the applications that you have and how can you make them prove a business case, go back to the ROI, the payback, the investment. For us, we have a team that focuses on that, but for everyone, you can't do it that way. So you really have to focus on, or think about how you're going to focus on getting that ROI. But, we can share horror stories all day.
Well, I was going to say, Paul, how many years have you been doing this AR thing?
You're going to make me sound old. About 18 years.
Has it gotten any easier?
Well, the technology has. Getting justification, maybe not so much, but I would like to just add on to what Zohair was saying. It all comes down to the return, and actually when you're building a product as expensive as a 737, say, it's not that hard to justify spending $5,000 or even $100,000 on equipment, headsets or whatever. Just saving one mistake is going to pay for that thing several times over. When you think about tracking the non-conformance, whatever it might be, traveled work, all the documentation that goes along with it, maybe certifications have to be done, all kinds of stuff. That stuff is extremely expensive. And so if you can spend, $5,000 or even you spend $100,000 on something to eliminate that mistake in the first place, that's not that hard to show. The problem is you only get that return if the adoption is there. So going back to the last question, adoption is really, at least from my perspective, is where we're struggling or a little bit hung up on at the moment. So we know the value is there. We actually did our own pilot to collect a bunch of this ROI data around wiring. I talked about wiring earlier. It showed that using AR, we were using a HoloLens, we saved about 20% of the labor hours to install wiring across this. It was at one of our aircraft. And the number of mistakes went down by 80%. So usually if you go faster, you would expect more mistakes. Or if you want less mistakes, you expect you have to go slower. But this technology allows us to do both, faster and fewer mistakes. So that was very clear. We have some numbers on the dollar savings per aircraft. No question that it is a positive ROI. The problem is, will people use it? And that becomes a question of, well, is there more benefit than there is burden? From the user's perspective, if they don't like the device or there are steps that aren't, let's say optimized, like for instance, our IT group, the way we've deployed these things, you have to go to a computer and get a QR code and then log on to the device through a QR code, and all these steps that are not really ideal. Every time you add one of those workarounds or those extra steps, it chips away at the willingness of a person to use it. So although we know the benefits there, convincing people that the plus side of using it outweighs all the inefficiencies and all the work, that's where we're at the moment. And I do see it shifting slowly, but to be honest, we've only had a few instances that have gone into true production and actually used every day. A lot of times we do limited kind of scope pilots, but yeah.
Cool. Austin, how's that resonate with you? Anything to what your business case looks like?
So there's a lot to add on to all of that. As Zohair mentioned, this is the part where horror stories are made of for all of us. But at the same time, you got to kind of look at it. At the end of the day, we have never had a technology that is available to us that can revolutionize learning in quite this way. And there's no other way that we've been able to share all these different knowledge points, all these different little tips and tricks, just everything that we can give to benefit an operator we're able to do now. We've reached that point. And so the argument's already there as to why this can be useful. And then once you prove it out, you can, even, I recommend always when you start this out, pick a small, process, but something that everyone touches. You do that and you get it on as many people as possible, and that's why you've picked, again, a small process and something that everyone does. You've immediately built in that kind of cultural acceptance as you've gotten all the new people to touch it, and you've gotten all of the, the longtime people who already knew this thing to touch it. So maybe that's not the most dollars and cents answer to this, but to approach it in such a way that it will make sense in the end run, that's how you do it, in my opinion.
Awesome. And yeah, how about Nobel? I mean, what are you seeing in the, how rigorous are you measuring the ROI on this? What are some of the things you're doing?
Oh, I got to do that all the time. I mean, you look at how much money does it save? How much time does it save? Like for in my industry, the scientists to do the work. How much more efficient is it? But at the same time, there's also implied savings, and what some of the people here talked about is when you have to troubleshoot something, or potentially in my industry, when a batch for medicine fails. How much money does that cost to repeat it? So if you can show that there's an ROI in terms of, hey, looking at a prior batch or prior history of an experiment that's ran and say, hey, if we were able to figure this out in real time, we would have been able to salvage this batch that is hundreds of thousands or millions of dollars. And that's already a return on investment in there. So it's trying to look at those opportunities and those examples of maybe failures that have happened on a daily basis, or not necessarily daily basis, but things that happen once in a while that you can easily pinpoint and say, hey, if we had some of this technology implemented, we would have mitigated that risk. So it's looking at it that way in terms of creative ways to provide that ROI. And as everyone mentioned, there's things in saving travel and things like that attribute to it. But think about those ways of trying to intensify that cost savings, because those are things that maybe senior leadership can understand a bit better and be ready to be challenged on that, because they're going to challenge you on those numbers. They're going to be able to challenge you on everything that you mentioned. And it doesn't have to be exact, but at least if you have a good structure of how you want to counteract these challenges of the amount of money that can be saved in terms of the amount of money that's spent to implement these technologies, it'll go a long way.
And if I could just add on to a little bit, what you were saying about the batches really made sense. You could also think about that not just in end product, but also in your machining, your tools, what you use. We have, machines that go down every day for whatever reason. When you train people how to use them properly, what the safety, measures are, and everyone's following it, that dramatically decreases, and you're not having to, spend downtime on down machines, and you're not having to pay to fix the machines to get more profit by actively running the parts.
Cool. And Jeff, you got any?
These guys said it all, man. Nobel and I are in the same space.
Yeah.
Paul said it good as well. We track mistakes, NOEs we call them, notice of events, deviations, right? So if we could save X amount of deviations or NOEs, it's a win right there. So it's not always quantifiable, like it cost you a few $1,000s to travel to Germany, but if you take this headset, it's not. Mistakes and NOEs are really our game of what we're tracking here.
Awesome. Okay. Well, we're just about out of time, but I think we got time for some audience questions. If anybody out there has any particular questions, we've got a couple over here. Just a sec. We'll get.
Just say your name and your organization for context. All right, Brad.
Throw.
Hello. Hi, I'm Michael Hyatt with Northrop Grumman. I'm curious about AR work instructions, about alignment, not alignment itself, but how did your end users react or manage the additional steps it takes to align the AR to the product? Because I know you may have different methods, but there's always something required from the end users to align to the product. How did they accept or react to those additional steps?
Yeah, I can take a stab at it. So, I mean, for us, we've tried to simplify what they have to do, obviously, and we've actually put quite a lot of work into that. So we typically install markers around the assembly, the fuselage. We're getting a little bit into kind of object recognition, but I have some thoughts on that. But with the markers, for instance, like in terms of installing them, we've written an algorithm. So our markers are not unique. They're not QR codes. There's nothing embedded in them. They're all the same. It's a Vuforia ViewMark image. And we put, say, 10 of them around the work area, and the user only has to look at any 3 of them in any order. It doesn't matter. And an algorithm we wrote will determine which 3 they looked at. So it also means they can't put the wrong one in the wrong place when they're setting them up. So just things like that. We've just made every effort to try to minimize the burden. Typically, I would say some of our earlier versions were more complicated, and we did get a lot of pushback and mistakes made. But what we've got now, I think, works pretty well, and we don't tend to get too much kind of pushback on that.
Cool. Got one more here?
Yep.
All right.
One more, let's do it. Yeah.
Yeah, I'm Stan Galansky with CB Technologies. We're a system integrator deploying these in process manufacturing, mainly oil and gas. I heard a lot of savings around time and improvement of getting things to production faster, but I didn't hear much about safety and what type of safety elements are avoided and how you would measure that, because we sometimes find that very hard to measure a safety factor when you have to predict something that's harmful not going to occur.
So I'll take the stab at the safety part. So safety is something that we build into each of these when we are creating all of our training templates here. And what we're able to do on a couple different levels. So one, because we're so safety conscious and we're walking you through how to use a machine, for example, we know exactly step by step where you are in that process, and we make sure that we instill those habits of having the machine, either unplugged or the power, being completely disengaged. We do all those kinds of things so that we have established those good habits to start with. And then when you are looking at how to quantify that, you can, look at that with your, overall EHS safety. Data that you have of, we've had this many types of accidents, historically, or these kind of, issues. This has gone down since we've done this by X amount, and you can do like a very vertical comparison to that.
Okay, awesome. Well, let's hear it for our fantastic experts up here. Thank you very much, and we'll be around for any questions afterwards. All right, thanks.